Hi, my name is David McComb. I'm the engineering manager here at Blacoh Fluid Control, and we are here to introduce our patent-pending hybrid valve. This is a combination dampener and back pressure valve. It's our first ever, and it has some very significant performance advantages that we'd like to go over. All right, so the setup that we have here, we've got a single diaphragm metering pump that goes through this system here. And on the back side, we have a standard back pressure valve with a dampener, and I have a valve here so I can put the dampener in and out. And then on the front side, we have our hybrid valve. So first we're going to show what our flow looks like with just the back pressure valve. Then we'll add the dampener into the system, and then we'll close that off, and then we'll put the hybrid valve in. And down here is our outlet where we'll be able to observe the flow. Okay, so our first test will be just the back pressure valve alone. So we can turn the pump on. All right. So the back pressure valve is doing its job. It's letting the flow out, but as you can see, the flow is pulsing, of course, because it's a pulsing flow off the pump. All right. Hear a little bit of valve chatter. Not too bad, but that's that. So the second setup we're going to show is the back pressure valve with the dampener in the system. So we open it up there. So we still have pulsing flow. It is definitely much smoother with the dampener than without it. Got a little chatter going on there, which is not ideal. But I still got pulsing flow. So why do we still have pulsing flow? Well, it turns out that most back pressure valves are really pressure relief valves that have been repurposed to be back pressure valves. And a pressure relief valve, you want to have the valve stay closed until you reach a certain pressure, and then you want it to open all the way and let the flow out. So although the basic design is the same, but the tuning is a little bit differently. And a regular back pressure valve isn't optimized to work with a dampener. And it is opening and closing before we get the full pulse into the dampener, because of the pressure has to vary in the dampener. As the pulse goes in, there's gas in the dampener, and it pushes up and increases the pressure. So it opens and closes the valve here before the dampener has taken the full pulse, and that's why we're still seeing that pulsing flow. All right, third setup. Third setup we're going to show is our hybrid valve. And the hybrid valve has both components together, and we have designed the valve to make smooth flow. So let's just put that in here. We will okay, so I've got this side completely closed off, and all the flow is now going through the hybrid valve. And you can see very smooth flow. Great performance. If you're looking for smooth flow, this is definitely a very good way to get it. There's a number of other advantages with this valve. One of the big ones is it doesn't chatter. And The reason that the other valve chatters is it's kind of a classic case of having a dynamic instability from too much gain. So the valve will open, the pressure will drop, and then the valve closes, and then it just kind of flutters back and forth. So the design changes that made this flow more smooth also get rid of the chatter for the most part. So, and also there's only 2 connections, so you've taken out a number of connections, which gives you a smaller footprint on the skid or wherever you've got it, and less leak points. So really quite a few benefits. Like anything, you have engineering trade-offs. When you, well, the design changes that we made with this make it a little bit more likely to get clogged than other systems. So if you have, particles in your flow, they might not be the best choice. So there it is. Overall, it's a huge improvement in the smoothness of the flow, as you can see. Well, thank you for watching. If you have any more questions, feel free to contact any of our sales team or our engineering, and or you can also look at blacoh.com/hybrid valve. Thank you very much.